Yes, thank you. Miluk from Britar. Yes, thank you. Yeah, okay, let's get started. So today we'll be talking about machine learning with Python. Okay, and then because machine learning is very big topic, we use it in our project. So I decided to okay, let's discuss one small topic of machine learning, so that hopefully we can do something about it. Yeah, so my name is Achmad Mardiansyah, and I'm from JLC Networks, Indonesia. Agenda, so we will review some prerequisite knowledge, because this is not a beginner topic, so we assume you already know some topics. At least you know how to do Python programming, how to do machine learning, and then the last one we'll be talking about OpenCV. Yeah, I mean just some tricks about that. Okay, so this is our agenda. So introduction, we are GLC, Garda Lintas Cakrawala. We are based in Bandung, and then our areas are training and IT consulting, and yeah, we do our own development for software, like GLC Radius Manager. We are partner for MikroTik, Ubiquiti, Linux things. Okay, and then my name is Achmad Mardiansyah, and I'm a Linux user since 1999. MikroTik user, Cisco user, Ubiquiti user, PHP user, MySQL user, PostgreSQL user. What else? Oh, Python users, and other Python library R, because we do some statistical things here. Yeah, so many technologies. Why? Because I'm doing as a consultant. I was doing a telco consultant previously, a long time ago, in the beginning of my career after graduating from school. Yeah, I do networking. I'm certified trainer, and then I have a LinkedIn account. Okay, so guys, if you have LinkedIn account, I would like to connect with you guys. Next, past experience, we do network support. We, yeah, most of the projects are related to the networking. Yeah, so we do like a migration from bridge network to routed network. So we basically we do three things: networking, system administration, Linux based, and then programming. Yeah, programming like PHP or Python. So most of our webinar are related to those things. So either related to networking, yeah, networking with MikroTik or Cisco or other brands, so networking stuff, and then sysadmin, Linux stuff like containers, Kubernetes, Docker, system administration, yeah, stuff like Linux stuff, and then the programming. So this is part of programming, the machine learning topic that we are doing today. So that was our past experience. Oops, I cannot move. Okay, about the webinar itself, we started from 2010, long time ago. At the time, there's no Zoom, so we were using Illuminate at the time, if you still remember. Yeah, so if you want to be a presenter, just feel free to inform us, and then we will put a schedule for you. Okay, about you guys, thank you very much. So guys, please, if you haven't introduce yourself, at least introduce yourself here, saying where you're from. Yeah, say hi. So we would like to connect you guys. So at least we know where you are from. Right. So prerequisite. Oh, okay. So I haven't updated this slide. Yeah. So we assume you already know Python. Okay, I will update the slides later. Sorry for that. Yeah, so the thing is, we assume you already know Python and machine learning, and after that we will discuss some about the OpenCV. Oops. Yeah, okay, about basic stuff. So this is Python command, okay. So by attending this webinar, at least we you know about basic programming stuff like variables, commands or keywords. So there are several words or that you cannot use as variables, because that one is already reserved for other purpose. For example, print, you cannot do that. While you cannot do that. If you use it, it will be confused. Is it a variable or a command? Okay, so at least we need to know. You need to know about the operations, the plus, minus, addition, subtraction, multiplication, division, modulus. Okay, this one is modulus. Array. Okay, at least you know the difference between list, tuple, and dictionary. So dictionary is the stuff that looks like a JSON. Okay, so you have a key value, and then in the value itself, it can contain another dictionary. So dictionary inside the dictionary, or a list inside the dictionary, or dictionary inside the list. So that can be that kind of combination is possible. The next thing that you need to master is loop. Okay, either it's for loop and while loop. Yeah, these are the two loops that is often used in Python. So in other programming language, you have a while loop and then do while loop. So in Python, you only have a while loop. Okay, so here you can use for if the loop is finite. If the loop is infinite, most likely people use a while here. And then as usual, you must have a flag that will be used to stop your loop. Okay, so and then here's the condition, and then this is the increment to make sure the loop is not doing iteration for forever. Python is can be procedural. Okay, so code is executed sequentially. It's easy to understand, faster to implement. It's natural. Okay, so it looks like when you read a paragraph, a newspaper. So usually you start from top to bottom. Program lines can be very long, so we need to find a way or to architect our code so that it can be managed physically, and then also manage our application logic. So for that one, usually we use functions. So we put the function name here, and then here's the indent. Make sure, I mean, as you know, Python requires indent, right? There is no brackets that that shows beginning and then end of the code. And then you call the functions and then put the arguments here, okay, based on the parameters that was defined on the functions. Okay, so that was it. Yeah, you can return data as a result of the functions. Okay. Okay, so we already know that we are using functions, and if in order to make our program more efficient, usually we put those functions into a library. Okay, so usually we set up a files here. So this is a file. Okay, and then inside the files, we put our functions or variables or many things over there. Okay, and then on the other files, we just import the files. Okay, and then we will use the things inside the file. So here it is. We call them. We call the module name, and then dot, and then we access the attribute inside the inside the library. Okay, so it can be method, can be attributes. Okay. So what's the difference between method and functions? Well, that depends. If you are using procedural, we call it functions. If you are using OOP, object-oriented programming, we call it methods. So method, usually we put it in the class. Okay, so that was it. Next is machine learning. So machine learning is located here. So I took this picture from, I forgot the name. Conway, yeah, Conway. Okay, so Conway. So this diagram is from Conway, and then this is just one way to define a data science. Okay, yeah, data science is a mix of knowledge from computer science. That's from his perspective. Okay, mathematics and statistics, and business or domain expertise. So we usually this is ours. Okay, so we are from computer science, we are from engineering, so we usually on this side, the green area over here, that's our domain. Sometimes we know about the mathematics and statistics because we took a course for that. Yeah, so usually we are in between here. Okay, we know mathematics and statistics. Okay, so it's a combination on both of them is machine learning. But when we do data science, we need other domain that is the expertise. So for example, we want to do analysis of automotive industry, like how far is the fuel, what is the correlation between or the predictions of a fuel consumption and the combustion chamber, for example. So that one we don't know. So that's why we need other people from that domain expertise to help us with the data science here. So usually when we do data science, it's not like what is it? What do we call it in programming? It's a full stack engineer, right? Full stack engineers means that it's a team of one, right? you do the back end, you do the front end, you do the SQL, you do the database, you do the API. So it's a team of one. It's a full stack engineer. So it's not like that. In data science or machine learning, we need somebody from that domain. So if, for example, if we are doing machine learning for finance, we need people from finance that can understand the parameters of the data that is given to us. Okay, so hopefully you understand the difference between the machine learning, data science, and then the mix between them. Okay, so yeah, with the machine learning, we can do things like this. At least from the data that we collect here, here's the data from our sensor, from our past data, and then we do collection using sensors, right? Sensors or past data, and then here's the data, and then we process the data, and then we get the information. And then after that, after we do analysis and production, we can get the intelligence, at least, for example, a model for the data, and then machine learning can do that job. Okay, so the data analysis level. Yeah, so this is this is a graph that explains the business value and then the complexity of our solutions. Yeah, so it shows the evolution of our applications. Usually when we develop an applications, we put a digital form, and then a user put data on it, and then we develop a reporting. Okay, it's very, the complexity is low, but the business value is also low. After that, after we put all the data, we can do detective analysis. We can do things like explaining why is it happened. Okay, if we are we are going further, we can do dashboard that can show what is happening now. And then going further, we can do predictive analysis. And then if we have a very big data, and then we can do a predictive based on the data that is collected, very massive. So here we can see that the data is very crucial. Okay, so because the present is the result from the past, and then the past is the key for the future. Okay, so what we are going through is the future. Okay, we don't know what's happening in the future, but we are using the past data to predict the future. Why? Because we believe, and then the data also shows that there is a pattern for what is happening in the data, in events. Okay, so that with past data, we expect to have ability to find the pattern. If we find the pattern, we can make the model, and then we can predict what happened in the future. Okay, so yeah, as you can see, this is from Kung Fu Panda. So today is a gift, so that's why it's called present. Yesterday was history, tomorrow is mystery, so that's why today is called present. So I like that one. Right, so yeah, moving forward to the machine learning. Machine learning is meaning you are learning data from the learning the data with the provided method, and then you get the insight from the data, and then the method can be supervised learning or unsupervised learning. Supervised learning, it means that the data that you have will be put on a label. Okay, so for example, if you want to distinguish the picture between cats and dog, okay, so you have lots of pictures of cats and picture of dogs. Okay, and then you tell the computer, okay, dude, hello computer, this is a picture of cat, this is of dogs. Okay, and then you leave one, and that you don't show it to the computer. Okay, so the data that you give to the computer is called training data. Okay, and then the data that you use to predict will be the data for testing. Yes, and then the computer will predict, oh, okay, this is dog or cat. Okay, supervised learning and unsupervised learning, meaning that okay, all the data is there, and then there is no label. Okay, you don't tell them. Yeah, and then the computer can find a pattern from that data. Okay, about the machine learning itself, there are several functions that can be done by machine learning. First is estimation. So most of the machine learning uh, functions or purpose or objective must be in this areas or this aspect. So first, either is we use machine learning for estimation purpose. Okay, so estimation, and then here are the algorithm. Okay, lots of them. Linear regression is very famous. And then if you want to do prediction or forecasting, okay. Yeah, we want to predict what is the oil consumption for the next month, for example, given we have 20 years of the data. Yeah, we can do prediction. And then this one is also good, yeah, for classification, okay, to detect whether it's a face of a human or not. Here we can use decision tree, Naive Bayes, KNN, linear discriminant analysis, lots of them. Okay, we just mentioned the name. Next is clustering. Here is to find, for example, here is to find, for example, we have a data, and then we want to see is the data is grouping or not based on particular criteria. So here, for example, it's very famous. It's a real data set. It's from Iris, right? Iris data set from UCI. Okay. So with this clustering, we can see that, oh, okay, so this kind of label, versicolor, setosa, or virginica. It's a very classic example when we learn machine learning. And then the next case for machine learning is association. Okay, this is, for example, we can use this in Tokopedia, Amazon. Okay, so for example, if you already buy product A, okay, and then there will be a recommendation. Other people that buys A also buys B, C, and D, for example. Do you want to add them? Okay, so that's example of association. Okay, dude, that was the. Hopefully, you can have an insight about. I mean, get an idea about the data mining. This slide is from Romi Satriawahun. Okay, so let's move on. We go to the computer vision. So computer vision is a library, can be used for Python or others. And then the capability is to do image processing and also the videos. Okay. And then related to machine learning, we can use the OpenCV here. It's like a face detection. So one aspect for machine learning is classification, right? Yeah, to classify this is human or not human. Yeah, so this is part of machine learning. So that OpenCV has a relation to the data mining or machine learning or data science. Yeah, those three things are overlap to each other. Okay. Yeah, so for example, face detection and classification. Anything else? No. Okay. So let's do OpenCV. Oh, yeah. So let's do live practice. So here I cannot allow you to log in to the server, yeah, because yeah, the server is not open. So I will just show you an example of a computer here, my own computer, and then this time I'll be using Windows. Okay. Okay, let me share my screen. Can anybody see my screen over here? Oops. Can anybody see my screen? Hello? Can anybody see my screen? It's a question.
Yes, we can.
Okay, great. Yeah. Yeah, so hopefully you can see the screen over here. Yeah. So what I'm doing here is I have a Python I have a Linux server here, and then here I have lots of files, and then I already installed the OpenCV and OpenCV library over there, and then the Python is also there. So the thing is, I want to display an application over here, but the processing will be done on Linux server, but the display is on my Windows box. You guys get it, right? So for example, I can start text size, for example, here. Yeah, so this is one example of, see, you can see, so I'm not using my own Windows machine for running the Python code. No, it's not. So I'm using my Linux machine for running my Python code. So everything will be there, but the results will be displayed here. Okay, so let's do some files, some simple files. Okay. So where is it? Okay. Yeah. So this is how you, one example of a code for OpenCV. I already put some here. So we import and then we display. Yeah, so this is OpenCV. Okay, as I said previously, so OpenCV is version, I'm using is here is version 2, right? And then it's already 20th anniversary. Wow, it's been around for 20 years. The library itself, I already cloned it. OpenCV GitHub, for example. Yeah, so here it is. And then I already cloned the OpenCV GitHub into my server. And then as you can see, there are several directories here, including data, Yeah, so the data here is contains the Haar cascade. Haar cascade is one algorithm that is used to detect um, objects like face or others. Okay. Yeah, some are requires license, but this one should be okay. Okay, let me check. I have cd home OpenCV. Oh, okay, so here it is. Git pull. Oh, yeah, it's owned by root. Okay, let me change the permission. Oops, cd home. Change home. OpenCV. Okay, should be okay by now. Yeah, git pull. So we are pulling the data from the GitHub. Okay, should be okay. So everything's there. And then either you can do compile from the OpenCV here. You can do your own compile, or sometimes there is a Python library that is already compiled so that you can just use them to install. Okay, talking to, okay, let's move to the first. So this is one example of how you use OpenCV. Okay, so first you do import and then you define variables. Sorry, an object. Okay, when you import that, you are instantiate the class of OpenCV library, and then you are accessing the method here, which is imread, image read, and then the image read is, for example, abandoned car. Okay, let's copy them. Paste, and then another example for another method that you can use is show, and then wait key, and then destroy all windows. Okay, so here, after that you finish, and then you can run the files. Okay, let me check. Oh, okay, sorry, not here. cd OpenCV. Oops. Yeah, Python file 101. Oh, okay. Oh, module OpenCV is not there. Why? Because the Python that I'm using is Python version -v, not mistaken. Yeah, it doesn't have yeah, Python 3.8. Okay, so this version is not compiled with OpenCV. So let's see if I have another Python. Okay, so there is a Python 3.7. So I will using that. And then run the files. Okay, let's see. Yeah, it's load up. Okay, a little bit slow, but it's okay. Okay, so this is how you use the OpenCV. Okay, so you display, you load and then display. Others, yeah. So that's how the code looks like. Okay, you add them, you read, and then you do display. Others is, for example, change. Like, for example, this one, another example code. So you import and then change this one here. You can do image manipulations, right? This one, then you can do flip, rotate. Okay, that's done. And then you can run the files. Okay, so the file name was, what is it? Okay, file 105. Okay, so that we can do, you can do rotate the image. Okay. So is there any other? Oh yeah. There is a. I haven't checked here. Do we have a video here? No, we don't. No, we don't have the video. So it means we cannot do this one. So I think there is a file here called Lena. Yeah, it's very famous, famous picture for image processing. Yeah, if you want to see the pictures, and then we can edit the files to Lena. We copy that, and then change the name. Oops. ENG. Okay. Okay. To that, let's try it. Okay, so this is how it looks like. Okay. So yeah, with the ability of hair cascade. Yeah, this one hair cascade. So hair cascade here has, for example, has a model or algorithm. So the algorithm is inside here in the XML format. Okay. So for example, a frontal face, for example. So as you can see, it contains the the model that we can use to identify the object. Okay. Is it finished? No. Yeah, still Lena. Yeah, you can download the image by yourself. You can just check Lena image processing, so to make sure that you are using the same page like I have here. Okay, so that's so this is a very common image for very common picture for image processing. Okay, so yeah, that was it. And then, okay, let me check the. Yeah, okay, so let's do the hard cascade um, algorithm. Okay, so here you import CV, and then we define the location of the classifier. Okay, so that as I said previously, one function for data the machine learning. Sorry, machine learning. Machine learning capability is maybe this one. Yes, is for classification, right? And then from the OpenCV here, from the hard cascade, we can use the algorithm as a classifier to classify whether it is uh, a picture of a face or not. Okay, so here I'll be using this one, frontal face default. Okay, and then I'll be reading the image, and then yeah, I can show, and then we gray the image. Okay, and then is the face. Okay, so this is so we load the classifier from this, and then we put into this. Okay, and then this instance has method inside, and then one of the method is to detect multi-scale from the gray image. So previously the picture is in color, so that's why we need to sorry, we need to convert the image. So this is the image here, a color image into the gray color, and then we use them here. Okay, and then we got it, the results, and then here we draw a rectangle. Okay, based on the detection. Okay, so this is the face that is detected. So we have full image, okay, which is this one, and then inside is the pictures that we detect face. Okay, so which is this one. Okay, and then we draw a rectangle on this one. Okay, okay, let's try it. Hopefully, fingers crossed. So file 201. Okay. Yeah, it works. Yeah. So as you can see, so this is our full image. Okay. And then here's the area where we detect content face. Okay. And then we did it with our cascade algorithm. And yeah, we did it. Okay, so this is one way for detecting um, detecting the image. Okay, so this is the process, right? Okay. So any questions so far? Seems like it's very quiet. Okay, so this is the image over here. Here's the face over here. Okay, and then you draw a rectangle over here. Okay, guys, so think anything else? Is there anything? Yeah, there is one here, files, where you can check on YouTube, perhaps. Or maybe I can use detect other other properties like this one. So instead of face, maybe we can detect the eye. Okay, so it's the same thing. So let's do this. Oops. Oh, okay, so let's check the modules. Let's check the classifier. We call it classifier. Make sure that the classifier is correct. So /home /OpenCV data. Okay. /home /OpenCV data R cascade. Okay, hopefully it's okay now. Okay, let's do it again. Hopefully it works. Yeah. Oh, now it's cool. It can detect the eye and then the face. Right. Okay, so that's how you use OpenCV for machine learning. Okay. Anything else? Okay, let's do other one. Okay, maybe we can use home +OpenCV /data. This is an example. Or let's try this one. So let's see if it works. Yeah, it can detect from the video. So this video is coming from YouTube. And then while the video is going, we are detecting the face on the fly. So because actually the video is based on the frame that consists of lots of images. Okay, so yeah, here you can use it. Yeah, lots of them. So let's close it. Yeah. Well, I think that's all. So guys, hopefully you enjoyed the webinar. It's been very quiet. I don't know. I don't know what happened. So hopefully you can follow along with the presentation. Any questions so far? Oops. Well, again, we already done our 1 hour here. Again, thank you very much for your attention. Okay. Sorry, I just copy and paste. So again, so what we need is your feedback. Again, feedback here. Your feedback is very, very important. So I put again on the chat box. So please submit your feedback, sorry, and yeah, to make us better. And also we have machine learning class. Okay, just contact our admin just contact our admin to go to our website and contact. And then if you are interested, there is a machine learning course that is based either based on R or based on Python. Okay, so currently, if you are doing OpenCV, the OpenCV is not available on R, as far as I know. So for OpenCV, better if you use Python for that. Okay, any questions? It's been very quiet today. What's going on? Any questions so far? So again, please, guys, submit your feedback here, please. Okay. And then, yeah, let us know what you thought about that. Okay. Now it's time to photo session. Okay, so please, guys, turn on your videos. Okay, let's take a photo picture here. Oh, okay, so I need to change the background. Yeah, so hopefully this one works. Okay. Okay, guys, please turn on your camera. Okay, thumbs up, and then I'll count 1, 2, 3. 1, 2, and 3. Great. 1, 2, and 3. Great. The next page? No? Okay. So it's been very nice to have you here. So hopefully you enjoy the webinar, and then we'll see you in the next webinar. Thank you very much, and then have a nice day. Keep safe, and then hope you enjoy the day. Again, thank you very much, and goodbye.